Hello, ladies and gentlemen. Today we're going to be talking about applications of the normal distribution and z-scores. So I know we've talked about z-scores before, and we've talked about standard deviation before and normal curves before, but so far all you know about the normal curve is the empirical rule and all the percents that fall within one standard deviation, within two standard deviations, or within three standard deviations away from the mean. But what happens if we get a K or a Z score like we learned in our last lesson that's not just 1, 2, or 3, or -1, -2, or -3? What if our Z score is now 1.5? What does that mean for our percent? Because our breakdown of our percents was only within 1, 2, and 3. So today we're finally going to find that application of what percent of people fall between whatever, or what percent of data values fall above the age of 50, or all those kinds of questions, like what percent of people, or how many people do these things, right? Or how many data values fall, or how many data values do these things. So what you're going to need is a foldable from me, a z-score chart from me that you should have gotten, or a table full of z-scores, and then a pen or pencil and a calculator. Okay, so we have 4 examples that we're going to go through today together. And I hope your foldable is correct. There's been multiple versions of the foldable, so if your problems are a little different than mine, feel free to cross off any of the problems and write the appropriate problem on my slide on your foldable. So all the problems in this video are correct. If your foldable is wrong, please just make corrections on your foldable. Okay, so example number 1. A survey by the National Retail Federation found that women spend on average $146.21 for the Christmas holidays. Assume the standard deviation is $29.44. Find the percent of women who spend less than $160, and assume that the variable is normally distributed. So we're going to assume for every single variable that it's normally distributed because we need the bell curve. So there's going to be multiple steps in each one of these problems. And the reason why our last lesson focused so much on that formula z is equal to the value minus the mean divided by the standard deviation is because that's our first step. Before we can find any kind of percentage, we need to find a z-score. So step 1 is to find the z-score. So find z-score using that formula. So step 1, so z is equal to our value, or the one that we're looking at is 160, minus the mean was 146.21 divided by the standard deviation, which was 29.44. And our z-score then as a decimal is going to be 0.47. So what we're talking about is if we draw a bell curve, and our average is 146.21 at that middle. Of course, 160 falls on the right side because if you think about a number line, 160 is greater than 146. But what we're saying is the amount of standard deviations away from that mean that it is 0.47. We've always talked about 1, 2, and 3, or -1, 2, and 3 being within with K, but now we're saying our z-score, or where it's falling, is 0.47 standard deviations away, so not even half of a standard deviation above that mean. So when they ask us find the percentage of women who spend less than that amount of money, here I'll use my eraser really quick, for the Christmas holidays, what they're asking is all this shaded region on this curve, they're saying how many or what percent of people spend less than $160. So what we're going to do, because like I said, all you know right now is the empirical rule and how to find the percent that way. But now we're going to introduce a new way to find the percent, which is with that table or chart. So we're going to find the percent, find percent with the table or chart that I gave you. Okay. So I'm going to arrow to the next slide. So our chart has, if you flip it forward and backward on the chart, it has a positive side where all the numbers in this column are positive, or a negative side. And the z-score that we're looking up is 0.47. So that was a positive. So we're looking up 0.47. That's the z-score we want to look up. And so it's a positive number, which means we're on this side of the table. Okay. So what you're going to do when you look up the percent in this chart, how you're going to do it is this column tells you the first digit and the first decimal. So we're looking for 0.4. And then this row tells you that second decimal. So we're going to find all the way till they meet And so all the way until they meet. So we're looking at 0.6808. So we found the percent because all these scores that are between the first column and the first row are all percentages, and they're all the percents for the appropriate z-score. So for the z-score of 0.47, our percent is 68.08, which I'll go back and write it down, excuse me, on example number 1. So we already did that. Sorry, I got to go back. So we found the percent on the chart, or the decimal, which was 0.6808, which means that our final answer is 68.08%. Okay, so actually on the bottom of your z-score chart, it'll show a little bell curve, and it'll show that like it's shaded on the left. So one thing to note about these z-scores, and of course you don't have to write any of this down, I just wanted to tell you about these z-score charts, is that these percentages only find, and that's what it's trying to tell you on the bottom, these charts only find the percent to the left of the z-score that you looked up. So because our problem asked us for the percentage of women who spend less than $160, because that is all to the left for less than $160, our percent was exactly what we wanted it to be when we looked it up in the chart. It was 68.08. So if we asked a question like, what percent of people fall more than, what we're going to have to do is we're going to have to do some subtraction, which will be example number 3, and we'll even look at another one, an example number 2, where we're finding between two values. So I just wanted to point out that this chart only finds the percent to the left of the z-score. So that's something to keep in mind. Okay, now moving on to number 2. So each month, an American household generates an average of 28 pounds of newspaper and garbage for garbage and recycling. Assume the standard deviation is 2 pounds. If a household is selected at random, find the probability, or percent, whenever they say probability, they mean percent, of its generating between 27 and 31 pounds per month. Assume the vary is approximately normally distributed. So if we start with step 1, like we did on the last example, step 1 is going to be finding those z-scores, right? So we got to find z-scores for those 2 values because they gave me two values, because we need to find the percent between these 2 pounds. So we're going to find z-scores for 27 and 31. So z is equal to 27 minus 28 divided by 2. So 27 minus 28 divided by 2 is going to be a negative 1/2 or 0.5. And then I'm going to do z for 31 minus 28 divided by 2. 31 minus 28 is 3 divided by 2 is 1.5. There we go. So the graph that we want to draw, what's happening is we have an average of 28. If we draw our bell curve, we have an average of 28, and we had a value of 27 and 31. And so the amount of standard deviations away from the mean for 31 was 1.5, and the amount of standard deviations away from the mean, that 27 was 0.5 to the left. That's why we say negative, right? So we want to find the percent or probability of this shaded region. But the crux of this whole problem, or like the pivotal point of this whole problem, is remember when we look up those values on the chart, it's only going to give us the percent. So if we looked up 1.5 on our chart, which we will in a second, it's going to give us a percent for everything less than 31, or that standard deviation of 1.5. And then if we look up negative 0.5 on our chart, it's going to give us everything less than that 27 value, or all that white space. So we're going to look up those 2 values really quick on our charts. So step 2, find the percents with the chart. Okay, we're going to find those 2 percents. So let's look. So the 2 we had was 1.5. So we're looking up 1.5 here. So we're going to go all the way down to 1.5. And then there is no decimal behind this, so it's going to be 0. So we're in this column. So it's 0.9332 is the one we're looking up. So we know that for this one, our percent with the chart is 0.9332. Okay, and then I'm going to look up negative 0.50 was the other one. So negative 0.5, which is all the way down here. And then 0.0 is going to be that first column. So it's 3085, 3085, 3085. Okay, so this was my z-score. Here's my percents. But remember, so 0.9332 is giving us the percent of everything below that value of 31. And then 0.3085 is giving us everything below that value. So our last step that we want to do to find between, so to find between, or the percent between, we're going to have to subtract. Okay? So we're going to take 9332 minus 3085, and as percents, it's going to be 93.32% and 30.85%. So if we subtract those two, we're going to get a total percent of 62.47%. So when it says, what's the probability of generating between that many pounds each month of garbage? It's 62.47%. So from the American households, on average, they're saying it'll be around 62% of the population for America generates between 27 and 31 pounds per month of garbage. That's kind of gross, but that's evaluating all that problem on number 2. Okay. Whew, that was a bit of a problem. Let's look at number 3. Okay, so an American Automobile Association reports that the average time it takes to respond to an emergency call is 25 minutes. Assume that the variable is approximately normally distributed and the standard deviation is 4.5. Approximately how many people or how many respondents will respond to an emergency in more than 35 minutes? Okay, so remember our step 1 is going to be to find the z-score. So find the z-score. Like we did in our last lesson, we were always focused on finding that z-score by doing the value, which is 35 minus the mean, which is 25, all divided by the standard deviation, which is 4.5. So then if I take 35 minus 25, that's 10 divided by 4.5. In my calculator, it's telling me it's a z-score of 2.22. Okay? And so what's going on with the graph, right? So 35 is 2.22 standard deviations away from the mean on the right side of the mean because 35 is greater than 25. So they're asking us what percent of respondents fall more than that. How many take more than 35 minutes? I hope it's not a big percentage. You don't want an emergency respondent to respond in more than 35 minutes. That's kind of ridiculous. So we're going to take a look at our charts. So we're going to find the percent with the chart. That's always been our step 2 on these problems. So find the percent. So 2.22, right? So all the way down to 2.2. So our z-score was, oops, sorry. Here, let me erase that really quick. Sorry. 2.22. So we are at 2.2012 because that's the decimal for 2. So this is our value, 9868. So find 0.9868. But remember, the percent on the chart showed us all the values to the left. So what we're going to have to do in step 3 is subtract again. So we're going to have to subtract. But this time, I'll say, or 98.68%, because the 98.68% found to the left. So if we want to find how many data values fell to the right, our whole curve should be 100%. So what we're subtracting is 100 minus 98.68, which is 1.32% of respondents take more than 35 minutes. I mean, that's really nice that only roughly 1% of respondents only take more than 35 minutes to respond, but that's still probably 1% too many of respondents. We should probably really wrap that up. We don't want an ambulance coming 2 hours after an incident. That's not going to help us. Okay, there's example number 3. And then the last one, example number 4 with the police academy. Okay, so one more example together that we're going to do. So to qualify for a police academy, candidates must score in the top 10% on a general abilities test. The test has a mean of 200 and a standard deviation of 20. Find the lowest possible score to qualify. Assume the test scores are normally distributed. So the first thing I notice about this problem compared to all the other problems we've tried today is it's telling me to find the lowest possible score. In the previous 3 problems, they told me to find the percent or the probability, which is a percent, under the curve. But this time they gave me the percent, and we need to find the lowest possible score to qualify to be in that top 10%. So what is really going on? So if we draw our bell curve, they said our mean, which is in the middle, is 200. We have a standard deviation of 20, which we won't label quite yet. And they want us to find what score has to go here on that x-axis of our bell curve in order to fall in the top 10%. So they gave me a percent, and I need to find the value. So what I'm doing is I'm kind of working my way backwards through all the problems that we've done together in the lesson. So we're going to start with the chart instead of end with the chart. And we're going to use the chart to find our z-score so that way we can find the value. Okay, so if we want to use the z-score chart, remember, we always have to use the number that shades to the left. So right now, if we're talking top 10%, the number we want to look up is 100 minus 10%, or 0.1. So the number we want to look up is 0.900. Okay, so we're going to go to the chart. So we're going to go to the chart and find 90% or 0.9000. Okay, so I'm going to arrow over to the chart. So when you're looking for a percent, you're looking in all of this. So we're looking for a score that's closest to 0.9. So right now, it's going to take a little bit. And because I know the problem, I know where to look. But if you haven't looked at the problem yet, you see it's 0.5, which is 50%. Okay, these are 60%. If I go down a little more, that's 70%. Now I'm getting into 80%. I'm just trying to show you where I'm looking. Okay, here we go. 88, 88, 88, 88, 88, 88. Ah, look at this. Here we go. In this row, we have 0.8997 and 0.9015. So unfortunately, we didn't find 0.9000 exactly, but we have 2 values that are pretty dang close to 0.9. So which value of these 2, the question is closer to 0.9? Well, the distance between 0.8997 and 0.9 is really dang close, and so is 0.9015. But ultimately, this 0.8997 is way closer to 0.9 than this one. So this is the percent that we looked up, which was 0.9. But remember, our ultimate goal was not to find the percent. We know the percent was 90. We found the percent. Great. But now we want to know the z-score. So I'll show you in just a second. So we looked up the percent that we wanted, right? And now we want to find the z-score. That's our goal. We wanted to look for that z-score. So we have to work backwards in the table. So if we go an arrow up, we see that it's 0.08 and we see that it's 1.2. So our z-score then is 1.28. So we use the chart to look up a percentage to find my z-score, which is 1.28. But what's the question again? Let me just arrow back. It says find the lowest possible score to qualify. Oh yeah, we want to find the value on this x-axis. So we just found the z-score, which is great, but now we're going to go back to that original equation that we learned in our last lesson, which is z is equal to the value minus the mean divided by the standard deviation, right? Now we know what z is. We used our chart to find z. It's 1.28. We don't know what the value is. That's what we want to solve for. And then the mean was 200, remember, way back from the problem. And the standard deviation was 20. So now you are just solving this algebraic equation to find our value. So we're just solving for x. We're going to multiply by 20 to get rid of that denominator on both sides. 20 times 1.28. Oh gosh, let me do it in my calculator. So we get 25.6 is equal to x minus 200. And then in order to solve for x, we have to add 200 to both sides. Add 200 to both sides. These are going to cancel. I'll write my answer up here. But 200 plus 25.6 is going to be 225.6. And what was that again? Pounds, score, something? Oh, find the lowest possible score to qualify. Okay, so that's what our title is. So 225.6 is the lowest score you can get to qualify to be in the police academy. To qualify to be in the Policia Academy. So 225. Okay, so to sum up, each one of these problems, examples 1, 2, and 3, we're using the z-score formula, that z equals the value minus the mean divided by the standard deviation, to find a z-score, to look it up in a chart, to ultimately find a percent for our bell curve, like what percent of people, what percent of things fall between these values, below, above these values. We were always looking for a percent. But another way you can solve using z-scores is they can give you a percent, like we did in number 4, and work our way backwards through the chart to get to that value, because they didn't give us a z-score. They gave us everything but the z-score and said, hey, what's that minimum value in order to qualify if we know everything else? So I know this was a lot, and I know this was a long video, so thank you so much for bearing with me through it all. We will get multiple tries in class with these problems because I know it's a little tricky. So just make sure you've taken really, really good notes, and make sure all of your problems are the ones that were in these slides, regardless of what your foldable says, and we'll keep practicing when we get to class. All right, I'll see you guys soon.